Hi friends, this is Syed Naimuddin Ahmed from MTech Mechatronics branch. My seminar topic for today is communication via parallel port. Communications. The word communication indicates sharing of data. In human beings, like we share our data through various means by through TV channels, through by calling face to face, or through phone. These are the types of communication. Whereas in system, the communication happens through data transfers. Some information which is transferred from one system to other system, that is called as communications transfer. And in this we are going to see about two basic data transmission method. First of all, the first is parallel data transmission method, and second one is serial data transmission. My topic for the study for today's seminar is parallel data transmission. But let me first tell you what is serial data transmission. In serial data transmission, the device sends the data single bit, means it's like that one data is for this information, for if data is transferred, it's one bit by bit the data is transferred. So what happened, the problem with the serial data transmission is that if you are going in a system, you are doing some multi programs, means 2 or 3 programs at a time, then and you have to work fast at that time, you need to work fast. But what happened, a single data is transferred for each means, so it will go in a line. So at the end of the time, you will lose a lot of time, means wastage of time will be there. So you can say the serial data transmission is slow process. When now consider parallel data transmission, which is my topic for today. Here the data is traveled bit by bit, but there are different wires are attached to it. Means if suppose 8 bit wire, you consider 8 wires. So from 8 wires, 8 bit data are transferring at a single time. So it helps in fast data transmission. The problem with this parallel data transmission is that when you transfer 8 data, when you are transferring, you can't transfer it for long cables, because for long cables you need in real world there will be lot of noises, and lot of problem will be from the surroundings, noise in the form of noise. So this will affect your lot of your data, which is parallel data which is traveling in a parallel series. So they may get interact each other, and the output data will have some different value. So to avoid that, we use single port there. But in short distance, like in computer LAN connection, you can use a parallel data transmission. Now the parallel data this has 8, normally in general 8 lines, 8 data lines. But in some cases like SCSI interface, it has 16 or 32 bits data transfer also. Now in parallel data communication, we just now went to parallel data communication. So here we are going to talk about its method of this data transfer. In parallel data communication, it's of two types: unidirectional and bidirectional. Unidirectional means the data will flow only in one direction, there is no two-way method. Whereas in bidirectional, it can go and come from the same wire. In unidirectional, in general, you can say it is simpler, means the best example for unidirectional is printer, means data is transferred from computer to the printer, and the printer takes the prints. Whereas in this bidirectional, you can say about any system which is any DAC system which is taking data from the system, and which is sending data to the system, and the system after the calculation sending back the data. So that is bidirectional. In unidirectional, we mainly focus on two types of sites: transmitting sites and receiving sites. These are only these two methods, means these 2 points, these two sites are actually these 2 points where actually the data transfer is happened. The transmitting sites what it do, it plays the data from its system into the data lines and inform the receiving that okay, data is available, you can take our data. And receiver on the other end, what it do, it reads the data line, okay, now information has come, so I have to take the data from the transmission line. That is the work of these two sides. Now this process is called handshaking method. Handshaking method, or you can say data transfer method. In handshaking method, what happens, the receiving the basic simpler process, you can say, unless and until the receiver's side say that I am free for, or available for the data transfer, they are not going to the transmitting side will wait for the data to get to it. It will wait, it will or else means okay, when when the receiving side said okay, now I am free, you can send your data, my earlier process is free, now you can send your data again. So in that way it can transfer it. The handshaking implementation, it generally has three lines: the strobe line, the acknowledge line, and the busy line. In the strobe line, it is generally, it is actually used by transmitting side. In this thing, what happens, it tells the receiver that my data is available, I want to transfer my data from my place to your place. Acknowledge line is on the other side, means on the receiver side. Here the receiver, it actually waited, means it checks, it calls the transmission line that okay, now I am free or I am ready, you can send your data. And the busy line, it is the most important line in general. It actually at the receiving side, it is the thing which connect the when the data should be transferred or not, it is decided by busy line. It actually tells the transmitting line that right now if there is some process going on at the receiving side, so it tells the transmitting side that okay, now the receiver end is busy, you can't send your data right now, you have to wait for that. That is the work of the busy line. Now we are going for transmitting side. Transmitting side means what what are the process happened in transmitting side. The transmitting side, as you can see, first of all it checks the busy line, it calls the busy line, it checks the busy line, and it asks whether the receiving side is busy or not. If the busy line is active, that means the receiver end is busy. So if the transmitting side will make a loop, means wait, and it makes a loop until and unless the busy line become inactive. Once the busy line get inactive, then only it can transfer the data. So the transmission side, it once it find out that the busy line is inactive, it places the data on the data line, and then it start its strobe line. The work of the strobe line is to tell the receiving end that okay, now I am ready, I am sending data. The work of that is that. And at the other end, the acknowledgement line is there, which will make the receiver end active so that it can take the data. So in that way the data is transferred from the transmitting side to receiving side. And once the data is transferred, the strobe line at the transmitting side, it get inactive and stop any data flow. And at the means at the receiver end, the acknowledge line, it will get inactive once it find out that the strobe line is inactive. Thus this process is done step by repeatedly for the total data transfer. Now at the receiver's end, what happened? At the receiver ends, the busy line, once the busy lines get inactive, the strobe line becomes active, and it starts the acknowledge line and asks them, starts the acknowledge line and say that okay, data, I am ready for the data, so you can give me the data. So they start reading the data from the data lines. The receiver, it waits in loop for it waits in loop repeatedly, and unless when the strobe line goes active. Once the strobe line goes active, all the data is transferred. That means all the data is transferred to this side. Once it gets inactive strobe line, then it make acknowledge line also inactive, and the same process is repeated over and over again for all the data to be transferred. Now, earlier we talked about unidirectional data transmission, means from one port to another, as in the case of printers, means how it prints. Suppose if you want to transfer data from one part to another, it generally happens in notebook, PS2 systems. In those things, we can see this bidirectional data, where we have the data is transferred in both ways. Here, what happened? Unlike in a unidirectional system, data is transferred in either, or means the transmitting and receiver side can change its place. Once the place which was once a transmitted side, it can become the receiving side next, and the receiving side become the transmission side. And in bidirectional data transmission, as you can see, I have given example of PS2 and notebook. It is one of the, means it is little bit harder than the unidirectional process port, because in unidirectional you have your fixed transmission side here and the receiving side. You don't have to worry much, means just transfer the data. Here the computer have to note out when to read the data and when to write data. That is the most important thing they have to do. So in bidirectional communication, the bidirectional port, they have extra sets of control lines which determine which side is writing the data and which side is controlling the data at that point of time. And after determining that, the same process like we have earlier discussed in the previous here, data where like transmitter sides, this rule, the whole process, and the receiver side, these whole steps are repeated. Then at the last, I am going to show you some this normal block diagram of this port which of 25 pins. Here you can see there is one section is called status register, which has which is 8-bit data. Then data register, where the data is read or write. It is also of 8-bit register, as I have already told that this communication is by 8-bit, except some SCSI hardware where it is 32, 16 or 32 bits. Then the control register is also of 8 bits. It controls the data process when the data is going to or for the each end of the system. Now this is the standard unidirectional port of PC, and here we have of the 25 we have considered only 11 lines, of which 8 data register is called the 8 data register, and 3 register we have used for handshake, means controlling. Now this is the chart of parallel port signals, means after what signal it shows what the signal means. The pin 1 here you can see it shows here, it means that the data direction is going to the output, so the polarity they have made it 0. So at the strobe line the data is still available, means data is still going on. 2 to 9 is the data line where the actual data is being transferred. The 10 is to the input, and it is of the acknowledge lines which is at the receiver side. It is active till the data is processed. Then the 11 input, it is the called as the busy line. As is shown 0, that means it is not busy, means it is inactive, means the data is transferred from the input to the output. The 12 input it shows is out of paper. It's generally used in the printer section. Okay, and the 13th number, which is also going to the input, it is shown as active. Here they have selected the printer as its output, and the 14th is the auto feed. The 15th you can say error, to check the printer's error. 16 is the whole diagram. This 15 pin 25 pin connector is of data connection between the system and the printer we are showing. As you can see, the 18 to 25 is the ground signal. The 17th is the input signal, means whether the printer is online or off. For that we check. Now I am going to show you some examples of this parallel port communication. The best examples are keyboard, disk drives, tape drives, SCSI adapters. I have already told it has 16 or 8-bit data transfer, also Ethernet adapters, joystick adapters in PS2s, then printers, lots of devices, and one diagram is also shown there. It's a DV25 25 pins connector used for parallel printer. Okay, and that's all for today now. Thank you.